In the last lecture, we understand that if there are two oppositely charged objects hanging from a ceiling by insulating string, they will have the tendency to attract each other. On the other hand, if we charge the other spheres with the same charge as the other, these spheres will repel. We can deduce from this that charged particles exert force with each other. This force can be described using what we call the Coulomb's law. Charles Augustin de Coulomb described the force between two charges using a torsion balance. He discovered an inverse square relationship between the electrostatic force and the distance of separation of the charges. He further discovered that the force is dependent on the quantity on each body, which is denoted by Q sub 1 and Q sub 2. He found that the forces that the 2-point charges, Q sub 1 and Q sub 2, exert on each other are proportional to each charge and therefore proportional to their product. Because of these findings, he was able to formulate the Coulomb's law. Again, Coulomb's law states that the magnitude of the electric force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Mathematically, we can express this law through the following equations, where F sub E is the electrostatic force, Q sub 1 and Q sub 2 are the charges that are interacting, R is the distance separation between two objects, and this constant value is the permittivity of free space with a value of 9 times 10 raised to 9 Newton square meter over Coulomb's square. For brevity, we can conveniently use this equation. Let us have one example problem. Other example problem will be discussed during your synchronous session. Here, 2-point charges Q sub 1 equals to positive 5 coulombs and 2 sub 2 equals to negative 3 coulombs are separated by a distance r, which is equal to 30,000 meters. Here, we are asked to find the magnitude of the electric force that Q sub 1 exerts to Q sub 2. Predict whether it will be attractive or repulsive. Let us try solving this. As mentioned, this problem requires us to solve for magnitude of force between Q sub 1 and Q sub 2. The individual charges and the distance that separates them are also given. The working equation we will use is the Coulomb's law, which is equal to K times the product of two charges, all over the square of the distance between them. Let us now substitute these values. We have a constant value of 9 times 10 raised to 9 Newton meter square all over Coulomb square multiplied by the product of our charges, 5 coulombs and negative 3 coulombs, all over 30,000 meters square. Let us remove the units until what is left is the Newton, which is a standard unit of force, the quantity we are interested in. Solve this in your calculator, and the answer will be F sub E is equal to 150 newtons. We are also asked in this problem to identify whether the force is attractive or repulsive. Since the given charges are opposite, we have attractive forces. In our next synchronous session, we will be solving this problem and other more complex problems relating to Coulomb's law. You may take a screenshot of this problem and try to solve, and we will verify if your answers are correct in our next meeting. But that is all for this week's module. I am Guillermo de Castro, and see you in the next video.